Hello, everyone. We will start in around 2 minutes. We're just letting people in at the moment.
Vasilios? Vasilios?
We can hear you, Christian. We can't see you yet.
Okay. Now?
We see only now, yes. Okay, good.
Okay. Hello, everybody. Sorry for being late.
Hi, Christian.
We start in 1 minute. We're just letting people in at the moment. Yeah. Okay, I think we can start this time. So good morning, good afternoon, actually, everyone from Brussels, or good morning, depending on the time zone that you might be. And welcome to our event on the role of life cycle assessment for chemical recycling deployment and policy making, decision making. So my name is Vasilios Rizos. I'm head of sustainable resources and circular economy at CEPS, and I will be the moderator of this webinar. Now, just a couple of words of introduction, and I think we are all aware now that there is really a growing interest on chemical recycling technologies. This is, of course, on the one hand, fueled by investments coming out from companies around the world, but also from policy developments that are taking place in Europe and beyond. And there is certainly an ongoing debate about the role of these technologies. How can they contribute on recycling to recycling targets and decarbonisation objectives? And within this discussion around chemical recycling, within this debate, of course, there are specific discussions on the advantages of the different technologies, so in terms of emissions reduction, and in terms of performance. How do they perform compared to each other, or in comparison to incineration, mechanical recycling? This is often a topic of debate, and we have seen in recent months and years actually a lot of information coming out from academics, research centers, but also from companies that have published their own assessments, and in some cases NGOs have also responded to these results. And we have certainly a discussion around life cycle assessment, or shortly LCA, which we will be using, I guess, often today in this webinar. And I think it is a good moment now, in line with the policy developments at the European level, to take stock of these discussions or of this information that comes from academia and business, and link it to the policy developments. And there are certainly a number of open questions that we would like to address today, starting from how important is LCA for decision-making and investment processes within companies. Are companies using it? To what extent? What are the key gaps? What do existing evidence tell us? Of course, what are the evidence that we can see in existing studies? I mean, can all of these assessments be compared in the end and have some coherent and consistent messages? That's something that we would like to hear the views of participants later, and our speakers, of course. And what are the key gaps we have at the moment? Whether there are any issues related to data gaps, transparency, something that the progress needs to be made in the future, and also what kind of how could these assessments be integrated in the existing policy framework, and how could be useful and beneficial for policymakers as well. Now, to navigate through these questions, we will combine today perspectives from academics doing research on this topic, companies, of course, that invest on chemical recycling technologies and use life cycle assessments, and NGOs that monitor the developments and contribute to the policy debate. So we have, for a start, we will start with Eropin Lin, who is Head of Technology Assessment Division, and Florian Keller, Research Associate, and they are both coming from the Institute of Energy Process Engineering at TU Berkantemi framework. I hope I pronounced correctly. Okay, then we'll continue with Martin Broren, who is senior researcher at C Delft. Then from the industry, we have with us Mayu Helin, who is head of sustainability and regulatory transformation at Neste. And then we will continue with Christian Kreger, who is circular economy expert at the BSF. And we will conclude with Lauriane Veillard, who is a policy officer at Will Zero Waste Europe. So as you can see, we have all of the different perspectives on the table, and I think the basis for a good discussion. Now, I had discussions with all panelists, and we agreed that all of them will start with an 8-minute contribution, which is, I think, enough to kick off the discussion and hear the different perspectives. And that's to really give us enough time then to also take questions from the audience and have an open discussion on this topic. Now, Q&A function of Zoom, you all know it, you all have used it, hopefully. So please, our participants, use it throughout the event, mention your questions clearly, as concise as you can, and why not also mention the organizations that you come from for us to know the perspectives that you bring to the discussion. The event is live streamed currently on YouTube channel and will be available later. So if you want to go back to any of the points, please, you can revisit the discussion. So there's no worries if you have missed any point or if some information was too technical. Presentations will be shared later. We always receive this question, so no worries. There will be an email shortly after the SEPS event where all of you will be receiving the presentations together with any links that the speakers would like to include regarding presentations and studies they have done recently. Finally, I should mention that the event is taking place of the SEPS Chemical Recycling Initiative that we have launched since a few months ago. And in this context, we will be doing a number of webinars and roundtable discussions. So this is taking part, this is part of this initiative. Now, with no further delay, I would like to give floor to Robin Lin and Florian Keller. Well, thank you for your time, of course, for being today with us. And I know that you have spent the past few months looking into different LCA assessments. So I was wondering, what results, what is really the key message that you can bring? And can we have a concise message in the end or not? That's, maybe a question for the later for discussion. Good.
Thank you very much, Vasilius. Thank you, everybody, for taking the time today to join us. My name is Robin Lee. I'm heading the Technology Assessment Division at the Institute of Energy Process Engineering and Chemical Engineering at the TU Berg Academy Freiberg in Germany. And I'm joined today by Florian Keller, who's part of my team and is basically our LCA expert in the team. So we have the LCA expertise here later when we go into more technical discussion. So this is a very exciting topic. I've been following SEP's activities and this series that they are doing on chemical recycling. And when we talk about chemical recycling, the question is really, how can we evaluate this kind of new emerging technologies so that policymakers and industry decision makers have the information they need basically to support their regulatory developments as well as investment decision. So I would like to start off these sessions with talking about LCA as a tool, a method that could support such activities, but specifically on what are the challenges of LCA for its utilization in the chemical recycling, or I will cut it short and say the CR context. So when we talk about LCA, this is a tool which is very much used to assess environmental footprints of products, of services, etc. But for its utilization in the CR context, it's challenged, for example, by a lack of clarity regarding the LCA boundary. This relates to the assessment scope, the interfaces of CR integration in conventional waste treatment and chemical process steps, and also what are the reference processes for waste treatment that should be taken into consideration. Another challenge relates, as is emerging on the market right now, is there's a lack of primary data. There's insufficient databases because we just do not have enough large-scale implementation of CR technologies to provide that kind of experiences and data. And at the minute, for existing LCA evaluations in this context, technology developers are using a lot of confidential information which are not shared, which of course hinders the transparency of the process. And last but not least in the European context, when we speak about chemical recycling, there remains a predominant focus on how we can generate new plastics out of plastic waste. And this neglects the broader applicability of chemical recycling for actually recirculating a range of carbonaceous waste back into the production cycle for chemical production. So these are some of the challenges that LCA will have to address and resolve for its implementation in the CR context. And as a first step in this direction, what's really necessary is we need to have a systemic view how CR, so chemical recycling, could be integrated into the conventional waste treatment and the chemical production value chain. So there are 3 building blocks to this aspect. The first one will be the conventional waste treatment aspect. So here we are looking, just let me change this so you can see this better. So when we talk about carbon-containing waste, on the one hand, we talk about waste, which is pre-consumer coming from production and processing, those residues, as well as source-separated, very plastic-rich waste. This could go through mechanical recycling, of which the pure strains could come out and be processed and regranulated as recirculate and be brought back into the value chain. But there's going to be residues coming out of this cycle, which is not suitable for mechanical recycling. And this can end up as RDF, so residue refuse-derived fuel. And this is something interesting as potential feedstock for chemical recycling. But in addition to this, we also have residual municipal solid waste, and not forgetting, in many parts of Europe today, right, this whole process of separating sources of waste is still beginning. So for MSW, if they go through some sort of preparation and pre-treatment step, what comes out as RDF, this is also a potential for chemical recycling. So this is one building block. And the next building block we are looking at for the reference system for such an evaluation would be our plastic value chain, on the one hand, going from crude oil and natural gas as raw materials all the way through the different steps, base chemical production, polymerization, formulation, down to plastics production. So the question is, chemical recycling, link these two together and couple them. But chemical recycling is not just one type of technology. Generally, when we speak about chemical recycling, we are speaking about 4 broad categories. The first of which is liquefaction. I would say a lot of you are very familiar with pyrolysis, which is one type of liquefaction technologies. As you can see here, it can draw waste from different parts of the system, making pyrolysis oil, which through hydroprocessing provides a naphtha substitute, which can be channeled back into the plastic production value chain. That's one route. The next route is gasification. Again, drawing waste from different parts of the system and going through producing a gas, synthesis gas, which is a mixture of CO and H2. And then the routes could be different. It could go through Fischer-Tropsch synthesis, and then you can go similar to pyrolysis oil as a naphtha substitute, or using the gases, either individually as CO or H2, or as a combination as base chemical production. You can integrate that. The next one will be depolymerization, where you're talking about purification and recovery activities to generate monomers for the plastic value chain. And last but not least, solvent-based purification. So where polymers are recovered. In this case, right, I have to highlight solvent-based purifications. It's debatable whether it can be considered as part of chemical recycling, but we have included it into our reference system because of similar process steps. So one thing I would like to highlight at this point, looking at this reference system, is what you notice here is that we are not just talking about the plastic value chain, especially for base chemicals. When they are being produced, that's the possibility that they can be used as intermediates and carry on into the organic chemical value chain. So this is this broader perspective, different types of waste with the possibility for the production of different types of chemicals. That's how chemical recycling can be understood in its broader potential. But of course, looking at this, right, it brings challenges for LCA evaluation. The first challenge, the assessment scope. Where do we go with the assessment scope? Where do we draw the line? And what we recommend is to do a combined application of the cradle to gate, so-called product perspective, with the end of life, so-called waste perspective. Here you see these 2 perspectives shown. On the one hand, on the left-hand side, you see the waste perspective, and the right-hand side, the product perspective, with similar process steps. Okay, but what's interesting is chemical recycling can be integrated into different parts of this process steps. And if we are looking at the waste perspective, the functional unit, right, comes from the quantity and type of waste to be treated, and we can expand this to include the corresponding chemical production. If we are using the product perspective, alternatively, the chemical unit, the functional unit, is looking at the produced chemical quantity, and this could be expanded to include the corresponding waste treatment. Just to put this perspective right next to each other so you can have a look. Moving on to another challenge for LCA in the CR context is the variations in the inventory balancing process. What we would recommend is to use best available technique, which is available for conventional chemical and waste treatment processes. Now, the challenge comes for chemical recycling. There's no BAT yet for these processes. So unique aspects of each of the 4 chemical recycling routes I mentioned earlier has to be considered then when you are setting up the life cycle inventory and also for the subsequent assessment. Another aspect is it's pretty unclear what kind of waste and product qualities are involved. And for that, carrying out the assessment, we would recommend to carry out waste classification according to the origins of the waste and also the addressed CR technology, and for the addressed products as standardized chemical qualities. Now, this is an issue which I think all of us who are working with assessment in the chemical recycling context has to deal with. We have data gaps, we have inconsistency, which actually poses a challenge to the comprehensiveness and the comparability of different types of LCA evaluation. We would recommend to complement primary data with process modeling when it is necessary to address these gaps and to apply consistency check just to ensure that you have comparable process chain. And last but not least, and this is a topic which has been brought up in diverse webinars, even the last webinar on the chemical recycling topic, is how do we deal with this, this apparent conflict between something which is conclusive and transparent for LCA reporting versus data confidentiality and proprietary information for the technology provider. We recommend the use of graphic non-reproducible data presentation in this case. What is very helpful is to have inventory checklists to support the evaluation and also the review process. And last but not least, in setting up a critical review committee to evaluate the LCA results, to engage a reviewer with expertise in chemical engineering to support this process. And you see that I have highlighted the checklist. Reason being, we have developed, as part of our project, checklists to support liquefaction, gasification, depolymerization, and solvent-based purification activities, just to guide such evaluation process so you know these are what I need to watch out for, or whether these aspects have been addressed also for the sake of the reviewers, to make sure that this is something which is comprehensive in carrying out the evaluation. Due to time constraint, this is not something that I want to go through in detail. I would just like to point you to the short policy brief that we have prepared, which I'm sharing with the link here. And this short policy brief, I would say, is a 12-page summary of a 150-page technical report on how we can overcome the challenges of LCA for chemical recycling. And in the report, we go beyond looking at LCA to also looking at techno-economic assessment, which is also key for assessing investment in this direction. This is part of a project which we have carried out, funded by European Climate Foundation. Thank you very much for giving us the opportunity to delve into this topic, which is very emerging, to contribute to the social political discussion in this field. So thank you.
Okay. Thank you very much, Ropin. Maybe you can stop your sharing. Yeah, okay, very good. A lot of interesting information also for the technical people in the audience that they will react later. Just as a quick follow-up question from me to you and Florian, you know, with that I'm not a technical expert per se, but we follow this debate. You actually made a concrete recommendation to move the focus, if I understand correctly, of the LCA assessments and of the debate in general around chemical recycling from a plastic to plastic approach to a waste to chemicals approach, which is very interesting. And I understand that there are methodological benefits to be achieved by such approach, and I will be curious to hear what other the companies and the other speakers think as well. But concretely, I mean, what benefits do you see in that following such an approach beyond methodological benefits, and whether you're not a policy making, but I'm sure you interact with them, and whether you think this will also bring some benefits from a policy point of view, given that some of the regulations we have in pieces of law at the European level are product-related regulations. So yeah, just to if you could dive a little bit into this recommendation, and we can take it further later then as well. Yeah.
Yep, maybe I just start, and Florian, please add on from your perspective after that. The reason we are recommending to expand this view from plastic to waste to chemical, the first thing is when we talk about chemical recycling, coming from the technology perspective, right? This is a technology which is suitable for the conversion of carbon-containing materials into intermediates and chemical products. And if you are only focusing on plastic to plastic, you are actually restricting the potential of chemical recycling. And this we find actually quite a big shame, especially in view of the current policy-related discussion on this topic right now, also at the EU level, but internationally, is that we are faced with a waste problem. And we subscribe actually to what the EU the waste hierarchy says is definitely you want to reduce if possible and reuse if it's feasible. That's definitely, let's say, the holy grail we want to go for. But then we come to the waste issue. And what the EU is striving for is really, okay, if there's a way for better design to recirculate pure streams where you can, with less energetic effort, bring that back into the production cycle, definitely. But even in this kind of mechanical recycling process, and we realize it through our dialogue with mechanical recyclers as well, is there are quantities out there which cannot be directly recycled in this direction. And then the qualities will be very wide and very dispersed. And by opening the definition of chemical recycling to be broader than just plastic waste, basically open the door to say that we bring in alternative methods as an, let's say, an alternative to waste incineration and landfilling for waste which is no longer feasible for direct recycling. Florian, do you have something to add in that direction?
Maybe two little aspects. So from a more applicational standpoint, when doing an LCA, we saw when we did like a review in the course of this project, we saw that like mostly like from the feedstock perspective, so the kind of waste that is applied, there's always focused on plastic qualities, plastic properties for this kind of chemical recycling process, which is not really actually what, like, especially when you focus on the groups of waste that applies, is not really a huge quantity, right? The bigger quantities, municipal solid waste and other streams have higher quantities and other critical criteria for application. So this is sometimes a little tricky when you apply it for chemical recycling. And also on the product side, I mean, most products or most LCAs focus on substituting base chemicals or chemical feedstocks anyway, right? So, but when you look into literature, when you compare, okay, there are some chemicals out there that are maybe not necessarily into the plastic value chain, but into the chemical value chain. For example, methanol, when you look into this, which can have a decent also environmental impact when applied in the course of chemical recycling, which is spared out when you just focus on the plastic frame. So these are some aspects too.
Very good, and that's good food for discussion later. So now we can move to our next speaker, coming also from the research kind of side, and we have actually another LCA expert with us, Martin Brueren. So Martin, I'm wondering how aligned is your research with the insights that we had before, or whether you see also some deviations in your findings.
Yeah.
Good.
Yeah, thank you. I was actually really happy with this previous talk, because not only do I agree with basically everything that's being said, it really overlaps with some of the messages that I also have in this presentation, but also because it already introduced some important concepts. So I don't have to, I can talk about other stuff. So I want to talk today about our insights for chemical recycling based on our life cycle assessment studies. And yeah, I'm also going to have to go quite fast because our time is limited. But when I talk about our insights, I mean CE Delft. CE Delft is an independent research and consultancy company based in the Netherlands. We have about 80 employees. We are not for profit and work for a large variety of different clients. And yeah, I also have a slide on what is chemical recycling. And this is a little bit simplified compared to the image that Ropin just showed. This is actually borrowed from the European Commission, but I quite like it because it's a simple explanation of, you can have a linear plastics chain where you're using virgin feedstocks to make basic chemicals, turning those into plastics, which are then used. And then we have all of these different recycling options. So mechanical recycling is quite established already. And then in line with what has just been said, we have these new options, which are in development. going back to different stages in this value chain. And again, I also had a comment about, together we're grouping them under chemical recycling. It's a bit of a misnomer for solvent-based purification, but it's basically the group containing gasification, pyrolysis, depolymerization, and solvent-based purification. The terminology differs a little bit from the previous speakers, of course. And these technologies differ not only in where they go back into this value chain, but also in their level of how far they are developed. And what we have been doing as CE Delft is a lot of life cycle assessment case studies, and we're in a way guilty of what Rope and Lee just mentioned. We do, in some cases, confidential research, and we cannot publish everything, all of the data that we get from the companies that we are working with. And the same goes also for critical reviews. We've talked with a lot of companies, but I'm not entirely able to share all of those details. So I think that's an interesting discussion point also for later on. Indeed, can we use checklists or other ways of being more transparent about the data going into these assessments? And then sort of the second branch of our work is basically at a slightly higher level, using the insights from individual case studies to provide insights. Given the current state of development, current state of knowledge, what can we advise to policymakers? Can we already make some scenarios for the Dutch government, for instance, on, again, plastics to plastics yield? It might not be as perfect as a plastic to chemicals yield, but this is the question that we got. And that's, of course, sometimes a limitation of contracted research. But I think this is actually quite interesting for policymakers, because we recently published this report where we worked with 11 or 12 companies, indeed assessing plastic to plastics yield, basically measuring if you have a given feedstock, 1 ton with a given composition, and you're sending that through different chemical recycling processes, how much new plastics can you get out of that? And one of the key lessons that we learned there is that these technology developers expect that the shorter loops, like depolymerization and dissolution, actually have very high plastic to plastics yields. But when it gets to especially pyrolysis, a part of the plastics going into the process are used as an energy source, and it's quite inherent in the process. So it leads to lower plastic to plastics yields. That might be pretty obvious to some people here if they are very familiar with the technologies, but for many policymakers that we spoke, they were actually already quite surprised by this. So there, when we speak about pyrolysis, the plastic yield is about 50%. So it's quite a bit lower than what you might expect from a dissolution process. But of course, it also depends on the specific inputs, specific technologies, etc. I'll skip these other bullets because I really want to get to this picture. And this is going to be quite debatable. And I'm very curious to hear how the other speakers view this. But I wanted to be a bit bold and sort of give an overview of how we currently view all of these technologies, keeping in mind all the limitations that were already mentioned in the previous talk. Things like, this is going to be a very simplified overview based on our current insights and based on the European situation. You have to keep in mind that technologies are still in development, and that also the environmental performance depends on the context. Again, highlighted in the previous talk. Keeping all of that in mind, I still want to put the technologies in here because, like I said, I want to be a little bit bold and give some overarching message in a way. And I want to compare them on 2 axes, which again are not the full picture, but I want to talk about output quality. Like, will these technologies lead to a very high quality output, which you can, for instance, use to make new high performance products or food grade plastics, and also CO2 emission reductions compared to incineration. So again, that's a scoping issue where you are really assuming that plastics are diverted from incineration. Okay, so I think I've already disclaimed this quite a lot, so let's start with putting in some technologies. Basically, when you talk about high quality mechanical recycling, closed loops, like the PET bottle deposit systems, that will be up in the upper right corner. You get very high output quality because there's not a lot of contamination coming into the system. And if you can replace virgin, or you're avoiding the production of virgin plastics, you also have a very high CO2 emission reduction. But there's different types of mechanical recycling. You also have lower quality mechanical recycling, where it might be sorted plastic coming from different sources. It might be contaminated with biomass or other plastics or entirely different materials. And that could affect the output quality. It might not be possible to make new food grade products out of it, for instance. CO2 emission can still be quite high if you're replacing virgin plastics. And then there's also mechanical recycling of mixed plastics. And again, it's quite debatable, but in many cases, it's not so obvious anymore whether you're replacing virgin plastics, so CO2 emission reduction goes down as well. So where do we put chemical recycling into this picture? We're currently expecting it to fall somewhere over there. Output quality can be very high because you're going quite far back into this value chain. You can, in most cases, remove contaminants, for instance, and ideally you will be able to make new food-grade products out of this. And that's possible both with pyrolysis as well as with depolymerization and dissolution. Also, both of these technologies lead to CO2 emission reductions compared to incineration, even pyrolysis. But pyrolysis has, in our expectations, slightly lower CO2 emission reductions because you're losing part of the feedstock going in, and that's, emitted. Depolymerization, dissolution, in our experience, show better environmental performance, which can come quite close to this high quality mechanical recycling. Again, don't take this as the final lesson on where do these technologies stand. There are a lot of other indicators to also consider. And indeed, we should take a systemic view. I'll talk more about that in a bit, but some key findings that we've discovered so far. Like I said, chemical recycling can lower greenhouse gas emissions. That's a very straightforward one. We do find that the shorter loops have better environmental performance than the longer loop chemical recycling technologies. And we've also, based on our research into these plastics yields, found a sort of correlation with greenhouse gas emission reductions. And we think this could be actually an interesting way for policymakers to monitor the contribution of chemical recycling to a circular economy. But indeed, again, as the previous speakers mentioned, there are more ways to look at this. And it's not just about making new plastics, it's about making the economy more circular, which could also be done by looking at plastic to chemical yields. Unfortunately, that was not possible in that research. I wanted to end with some notes on this life cycle assessment research, because I've been quite bold with showing some results, and there are more disclaimers actually required. I think this overlaps with what the previous speakers also talked about. We should be careful when interpreting LCA results. They're always valid for a specific scope and a specific context. And there are different methodological approaches being used. Again, product or waste perspectives are quite different. Even if they're based on the same data, you should be always careful when comparing those results, of course. I also think there's still a need for more case studies, because I've only shown you results right now, which mention the carbon footprint, and there's a lot of work on carbon footprints, but there are other environmental aspects that should be definitely considered. And again, in line with the previous speakers, we should move beyond just looking at prospective studies. Ideally, we would use more data from real-world operational facilities using real-world feedstocks. And a lot of the companies we are talking to don't yet have that data available. So I think there's still a need to do more and be transparent about that. And the final point, I think it was summarized before as we need a systemic view. And I've shown you some results on some indicators, but there's a lot more to consider. Can we reduce the amount of plastic waste? What are the waste streams that are available? What is their composition, and in which technologies could they be treated? Which technologies can deal with a combination of maybe plastic waste, but also biomass waste? What does the economics look like for all of these technologies? So don't take the results I showed you for the carbon footprint as the only indicator to consider. I think I'm already past my time, but if there are any questions, feel free to get in touch, and I'm looking forward to the discussion.
Thanks, Martin. If you could, stop sharing your screen.
Where's that button? Stop share. There we go.
Okay, very good. Many interesting points that we'll raise in a discussion later, I'm sure. And on the hierarchy and on the data, of course, we have two companies with us, so I will be interested to hear your perspectives, and maybe we can have an interaction later as well. Now, I was wondering, you presented, of course, a slide which includes some form of kind of a ranking, and of course, you try to put many caveats on it, and of course, people will interpret in different ways always. You know how it is whenever there's a ranking presented. Mm-hmm. Now, I was wondering, coming as an outsider, looking at all of these studies and the assessments coming out, with so many different plastic waste streams and technologies in theory fit for different kind of streams. I was wondering, does it still make sense, you think, methodologically, and you still think it's of added value to have such a ranking, or whether the discussion maybe could even in the future move forward towards another discussion, you know, instead of having a ranking of a general ranking, like what kind of mix we could have of technologies, or how could technologies perform with regard to specific waste streams? Yeah, I would be interested to hear your views on this, but also what other speakers think about this later.
Yeah. No, I mean, let's have this discussion later on, especially, but you're right, of course. This is a very simplified view. Ultimately, you want to have a more integrated view on which waste streams do we have available and where could they be treated most environmentally friendly. And indeed, not all technologies are suitable for the same waste stream. So indeed, it is an oversimplification, at least a simplification.
Okay, good. No, let's discuss about this again later. And yeah, I think it's good now to hear the perspective of the industry. There was a lot of knowledge, theoretical, I don't know, academic. I'm wondering how applicable this is for the companies as well. So that's one of my questions, I guess, to both of you. But in general, I'm pleased to have with us two experts from two companies that they're investing on this, and they have used in different contexts LCA assessments. So we start with Maju Helen. Thank you for your time. Thank you for being with us. I know it was a lot of information before. So what are Neste's view on this, on LCA and chemical recycling, and whether you have any reactions as well to what we heard earlier? Yeah.
Thank you, Vasilios. Can everyone hear me? Okay, well, thank you. So thanks for excellent openings for my co-panelists, and good afternoon, everyone. So I'm Maju Helin, work for a company called Neste, where I head sustainability and regulatory transformation in the business unit that serves polymers and chemicals industry with more sustainable solutions. Let's see how I can change the slide here. Okay, I think now we are there. Okay, so Neste runs 3 businesses in the area of renewables. Those are renewable polymers and chemicals, renewable aviation, and renewable road transport. But today I will talk about Neste's activities in its polymers and chemicals business, and in particular I'll focus on chemical recycling. So Neste has an ambition to process over 1 million tons of waste plastics annually by 2030 through chemical recycling activities. I guess we all know that there's a lot of waste plastic produced every day, and the amount of waste is predicted to nearly double by 2040. Therefore, it's of very high importance that waste is mechanically recycled to its maximum. However, we know that not all waste plastic can be mechanically recycled, and therefore I see that therefore we should also introduce other activities to replace incineration and plastic landfill, and of course also prevent litter for those streams that cannot be mechanically recycled. We are a firm believer that there is no silver bullet, and therefore believe that chemical recycling will play a complementary role to product design, reuse, reduction, and mechanical recycling activities. And we think chemical recycling will be an important addition to the portfolio in order to upcycle, in other words, improve material quality of recycled waste plastics where it is challenging solely with mechanical recycling. Chemical recycling will also enable efficient use of existing facilities when virgin fossil resource use is gradually phased out. On this slide, we've illustrated a circular plastic value chain. And on the light blue box, you can see Neste's role in bringing waste plastic back to the polymer manufacture chain by liquefaction and upgrading activities. And what does Neste then actually do? As of today, we've been already refining liquefied waste plastic at industrial scale since 2020. We also just recently received a 135 million euro grant from European Innovation Fund in order to further implement pre-treatment and upgrading capacity at our Porvoo refinery in Finland. In addition, we are also aiming to build a liquefaction capacity in the Netherlands together with Travago. So chemical recycling has clear benefits that fit into the LCA methodology categories. For example, through chemical recycling, we can achieve reduction of abiotic depletion potential of fossil fuels, as chemical recycling clearly helps to reduce dependency on crude oil by keeping the carbon in the material loop. We can also detect a clear climate impact reduction when we consider chemical recycling as an end-of-life option instead of incineration of hard-to-recycle plastics. But there are also environmental benefits that are typically not measured exactly by LCA methods. Such benefits can be seen to develop circularity of plastics, therefore diverting material from landfilling, incineration, and creating a financial incentive for preventing litter. Chemical recycling can produce virgin quality materials. This was something that my co-panelists also touched upon already. And quality of the recyclate is something that we see where current LCA methods do not give a clear answer to. However, quality aspects are an important part of the equation in many sensitive end uses such as medical and food. Quality of material is also linked to material reuse and recycling, and therefore seen as an important element in this big picture. Okay, so we've seen now that there are clear environmental benefits linked to introduction of chemical recycling. We also, what we see as a company, as an industry, we see that there is high interest in LCA information by our downstream partners. We also see that LCA seems to become quickly a license to operate from the regulatory side. Maybe we're not yet there, but this is the trend that we are detecting. But are we there yet to create regulatory requirements based on LCA? Are the methods already developed enough for that? And what are the gaps related to LCA methodology that we see should be solved before creating regulatory criteria that is based on LCA? One of the biggest challenges is, from our perspective, the multifunctionality of waste plastic recycling. This is the functions that I mention here is waste treatment and material production together. And these kind of multifunctional system, I believe, were not considered when the existing LCA methods were creating. So therefore, addressing multifunctionality should be considered when developing next level LCA methods. We've also found it a bit challenging to compare conventional linear value chains with the new circular ones. And obviously, this is also a field where methodological development would be very much welcomed. Another point of view that I welcome in the LCA method development is how to incorporate system level changes in product LCAs. And as already mentioned, the quality aspect is something we'd like to be addressed by LCA to even further level than it is as of today. I think that's all from my side to begin with, and happy to continue the discussion.
Many thanks, Mayu. Yeah, if you could stop sharing your screen. Okay, very good. I have two quick follow-up questions for you. The first one, you in your last slide, you mentioned the multifunctionality in LCA, and you mentioned the need to take into account waste treatment and product production. So I was wondering concretely what you meant here, is that the LCA assessment should take account emissions in both these stages, and it doesn't happen so far. Maybe if you could just clarify this. And the second question is, actually comes from our audience, Danielle Pacifici, who asked, true, why a company should provide more information? Why now and why? What is the business incentive? So That's something I would be curious to know. What is your incentive as Neste to share more data, even if this drive comes from academia? And I will be curious to hear also what Christian thinks about this later. Yeah.
Sure. So quickly trying to answer your question. So on the multifunctionality question, so what I mean is that when we introduce a waste to materials value chain, we are doing both waste treatment and material production in one value chain, whereas the comparison would be two different functions, like two different value chains, waste handling and then manufacture of product from virgin source in two different buckets, if you will. And so the comparability becomes difficult there because multifunctionality has not been exactly what was LCA designed for. Then you ask, like, what is, if I captured your question right, so what is motivation for us to serve downstream with more data around LCA? Well, obviously we want to serve the market to the best extent that we can as a company, and of course we are there to our purpose is to create a healthier planet for our children. So of course, if we don't have any data to showcase this, then obviously it is hard to showcase that we are moving to the right direction. So I think at some level, data is definitely needed.
Okay, very good. Yeah, and as I said, we will come back to discussion on data. So now we'll move to Christian Kreger from BASF. Christian, thanks for being with us in between your meetings. And there was already quite a lot of inputs, but I know you have quite a few points to raise through your slides. So yeah, please go ahead. We're waiting for your inputs. Yeah.
So I share my screen?
Yes, please. Yeah.
Okay. So you can see it?
Yes, all good.
Okay, perfect. Yeah. So many thanks for the good contributions from the previous speakers on the chemical recycling and also LCA. What I would address is again also and confirm that from our BASF perspective that chemical recycling is really needed in terms of the waste perspective, that we have to deal with the increasing challenge of plastic waste. Second is I want to address is the credibility of LCAs. What needs to be done that we generate credible LCAs? And I also would like to show you real results of LCAs, but not only the BASF ones, but also from a broader view from different stakeholders. I give you a small review on that. And in the end, I also would finalize this impulse with the way forward on the environmental impact assessment of chemical recycling, because there still needs to be done for sure. There's already a lot already there, but still there is something also which we still can improve for sure. Okay, let's dig into why do we need chemical recycling. I think the easiest way to look into that, sure, we can generate new recycled products which are interesting for downstream customers. We can give them an incentive for that. That's one reason. But I think the other reason is when you look into the systemic perspective on the waste. Yeah, you see here plastic waste from packaging, household goods, and automotive and construction in the perspective until 2050. And even in 2050, we will still have in Europe, that's European figures, there are 35 million tons of plastic waste. So there's a potential to reduce and substitute, clear, but still you end up with 25 million tons of waste. And even when chemical recycling will be applied, still there is a lot still be landfill and others. So we will have a big plastic challenge independent from chemical recycling in future. And what Systemic says, okay, if we think that specific waste streams from packaging industry, from automotive industry, from construction industry can be replaced to chemical recycling, then chemical recycling will contribute to, in total, let's say 18 million tons of waste. Oh no, that's not 18, it's 10 million. 11 million tons of waste. So, and to generate their new materials. I don't like the topic of plastics to plastics. I know that the plastic regulators like that, and some other people, yeah, but I don't like it, because I fully agree with Rupin. We have to tackle plastic waste in an open way, independent where it ends up. It ends up in plastics, it ends up in chemicals, or wherever. Yeah, we have a certain waste issue with plastics, and it doesn't matter where it ends up. So all in all, chemical recycling, to my opinion, is needed. It's independently also seen by many consultants, circular economy consultants, that can help us a lot to challenge the plastic waste. Now coming to LCA on environmental impact assessment. What needs to be done that really we trust that it's credible? Yeah? And there are already a lot done by many millions, but many experts, yeah, who standardized in a way this tool. First is LCA shall be calculated and reporting according to the harmonized global ISO rules 4040, 4044, for example, yeah, because this is the common sense or the common consensus around the globe how to perform LCAs. Second is, especially for critical topics like chemical recycling, we say it shall be also reviewed, but not only by one reviewer, but at an independent review panel of minimum 3 reviewers who have a certain name in this or expert role in this environment. Next is for sure use of high quality data. I think some already said that. We as company, BASF, we were collaborating with Quantafuel, with Plastic Energy to get also those primary data from their plants, yeah, and also to include our own primary data from our plants, and to have really the best possible results getting out of an LCA. Transparent communication, especially for such disputed topics like chemical recycling, is very important. And we should also do a transparent communication in the public and discuss it also with the public, like today. Yeah, we have done also a scientific publication, see it on the right-hand side, also link. Yeah, that would be also, I think, the final solution of being really transparent. And make stakeholder events like this. We as BASF, we have organized one with 800 people just on the topic of environmental assessment of chemical recycling. Yeah. And we see still also today with 120 participants also still very interested on this topic. Review, yeah. What is around by different stakeholders, not only from BASF? Do we have common messages? Do we have differences? We have reviewed more than those mentioned studies, but those 6 or 7 players. We have the JRC from the European Commission, KIT, that's a university in Germany, CDELF we know, TNO is also from the Netherlands, Consumer Goods Forum, a platform with 400 brands, and also BASF in this case. The common conclusion of all studies that chemical recycling is the preferred option compared to energy recovery incineration. That's also something very important. You have also be specific if you say something better. It's compared to incineration or energy recovery, the better solution in terms of CO2 emissions. Consumer Goods from TNO, BASF, and KIT, they also say that compared to fossil plastic, that would mean, for example, fossil polyethylene compared with a polyethylene coming from chemical recycling. Also here, chemical recycling can reduce the CO2 emissions compared to fossil plastic. And for that, to elaborate that, that's also a discussion on the method. 3 organizations have used a system expansion method. Because for circular systems, it's not so easy to show the society benefit which chemical recycling has. And therefore, sometimes needs to be new methods also be developed, like in this case by these 3 organizations. Also, the KIT says, and that's also important policy-wise, complementarity between mechanical and chemical recycling results in additional CO2 savings and helps to achieve recycling targets. So that means that not chemical recycling is competing with mechanical or vice versa. it's the complementarity solution which is the final goal for us to reduce CO2 emissions to the maximum. We also have seen that from the waste perspective in the first slide from systemic, that there is a mechanical recycling and chemical recycling should be combined to tackle the waste issues. On the right-hand side, you see an image from CA Delft about the reduction in comparison to incineration. Compared to fossil feedstock, we see here on the right-hand side polyethylene. On the left-hand side, you see the process emissions of chemical recycling plus the chemical production, which is actually higher. But there is a societal benefit if you're using waste streams coming from incineration, where you do not have any CO2 emissions anymore if you can use that for a second life cycle. And therefore, this credit can be accounted also in LCA, and that's what we have done. And that's the system expansion, what I have described before. System expansion method. Is that already used, or is it something unique method which is only used by BASF or others? No. We have also in politics at the European Commission, also the former PEF formula in the JRC, they were using this approach. Also the Argonne, which is a highly reputational institute of the US government, is also using this method. Research institutes like JRC I mentioned already, also TNO partly. Industry, several industry players who are engaged in chemical recycling are using that, that method also, and also the Consumer Goods Forum, where Sphera and Quantis and other LCA consultants also are taking over this method and applying that for circular systems. What is now the way forward for us? What needs to be improved for environmental assessment of chemical recycling by LCA? I'm not talking about toxicological evaluation, talking about environmental impacts which can be done by LCA, like for example, say CO2 emissions. Further develop LCA method for improved holistic evaluation. That's also something we still always should consider. Also, I encourage my colleagues from industry, to communicate also more open their results and their methods in an open mindset and discuss it with stakeholders like today. Standardize LCA rules for circular systems, important, like this Amsterdam system expansion. We need to standardize it that we all industry players, consultants, research institutes are using the same methods for the same thing, that we can compare the results much more better than it's nowadays. And the other is, because chemical recycling is still very innovative and we will have to do technology improvements still, that's correct. It's not an academic process. It's already used in industry where we can use waste streams in real life to make recycled plastics again. But for the environmental aspect, we need more waste streams in those LCAs to be discussed. And I know, Martin, just from the theoretical point of view, I think I can follow your assessment of the different recycling methods, But in the end, it depends case by case in the real case. Because for mechanical recycling, on one extreme, the process emissions are maybe lowest. But if you take the whole life cycle into account with all those losses in the sorting plant or after the sorting plant, because you cannot use everything in the extrusion process in mechanical recycling, this has to be taken into account because it's our additional CO2 emissions which goes into the air by incineration. So this needs to be holistically be looked at, and therefore I really encourage more to be more specific on waste streams, to be also holistic in a view, to look in waste to chemicals perspective and not only plastics to plastics perspective, which could mislead the conclusions on chemical recycling. And I'm very open and I'm looking forward to the discussion and your questions. Thank you.
Christian, many thanks. And if you could stop your sharing, Good. And Martin can also come back later and respond. just to remind everyone, you can use the Q&A function to ask your questions now throughout the event. Don't hesitate. And yeah, Christian, very quickly, you had one interesting conclusion. I think we heard it before, that chemical recycling is the preferred option compared to energy recovery and incineration, or that there is, let's say, conclusive. This has been concluded in research assessment. So if we can agree on this, I was wondering, what do you think is really the way forward then from an LCA perspective? From a BSF actually perspective, what do you think is the way forward if we can conclude, we can agree on this? And secondly, the question on data sharing, which was also raised by the audience, companies can make different claims. I think you know this well. NGOs as well, they can challenge this. But I don't know if we will ever reach the point where we can say that we have the perfect level of data availability. But yeah, if you could be a little bit more concrete on practical level, how far can BSF go in sharing data, taking into account competitiveness concerns also that the company might have, that's something that, I would be interested to hear your views. Yeah, 2 questions in one, but I know you can be concise and respond. Yeah, okay, thanks a lot.
From the data perspective, I mean, surely process data are confidential data, so usually we do not share, but aggregated data, for example, if somebody asks for BSF for a product carbon footprint of a BSF product which comes from chemical recycling, we do that. Yeah, so we are very open to that. Yeah. If a competitor will ask us for data on process data, we will not share for sure, because of we are restricted. If somebody comes from academics to us and ask us also for helping to improve their LCAs, we're also open for that, yeah, because we would like to have really the data quality be improved. But for sure, in general, LCA, how you can make it better on a data needs to be the LCA experts have some access to databases. Without databases, you are lost in the LCA. And the databases are depending on the quality of the input data there. Yeah, and policy has also seen this, and therefore has developed also a database in the respective of the product environmental footprint. And those data shall be really open to the public. And there shall be also included data on chemical recycling for sure. Yeah, and I'm pretty sure that the Commission will go in this way, especially for such innovative technologies, to have more level playing field for everybody to use such data that they will provide us through this to this channel. Yeah. And the other one, future of LCA on chemical recycling. Once again, I think we need more studies on specific waste streams. Yeah, because I see theoretical studies on polyamide or on polypropylene or on polyethylene. Yeah, these are a lot of our theoretical studies where it could end up in 20 years. But we need more realistic studies on case studies, how is it done today and what is the potential for the next 20 years. Yeah, and including all those aspects of waste streams, of processing, pre-processing of the recycling process, and post-processing. Think about pyrolysis oil needs to be refined still before it goes into the chemical industry. There is still some data to be evaluated also in LCA still. Yeah. So therefore, I see that more on real LCAs or LCAs on real data to be needed on real waste streams, how it could be implemented in chemical recycling, also evaluated in LCA.
Okay, many thanks, Christian. We'll come back to this point. So we move now to the last speaker for this webinar. We have with us Lauriane Veillard from Zero Waste Europe. Lauriane, there was a lot of information coming before you. I know it's a little bit unfair because you have already prepared kind of your slides, but any further reactions are always welcome, even towards the end of your contribution. But I'm interested to hear where Zero Waste Europe stands today on this evolving topic, because there's a lot of knowledge that is evolving as well. Yeah.
Yeah, sure. So let me share my screen. Sorry. Sorry, I have some technical issue. Is it now better? Yeah. So, so first of all, thank you for having me here today. And so I'm Lauriane Veilla, Policy Officer on Chemical Recycling, working for Zero Waste Europe. And I will present the more civil society perspective when it comes to LCA on chemical recycling. So the current state of play, we all agree we need some kind of standardized on LCA to have transparent life cycle assessment and to be able to make true comparison and to know the real impact of chemical recycling. So in our previous paper, Understanding the Environmental Impact of Chemical Recycling, we noticed there is a lot of discrepancy between different LCAs, thus impairing any comparison between different chemical recycling technology. And this is also the case and has been noticed by another study that has been published a few months ago. So it's really important to have standardized LCA, and this also be able to compare different recycling technology. And we also, in our preparation of our latest report, have been meeting some difficulties to compare different recycling technologies. So it's there's really a gap that we need to fill when it comes to assessing the environmental impact of chemical recycling. So I will focus on 3 different points. So the first one is on the focus of end of life. So the most important is to have a end of life perspective that it can also be called waste perspective. The idea is to compare recycling technology. Indeed, the idea is to compare mechanical recycling with chemical recycling, for example, because both of them have the same goal, reintroduce materials, and both of them deals only with waste. This is not a manufacturing technology. This is just recycling technology, as it's important to take into account. And both of them have also some limitations that we know. So for example, they cannot handle all type of waste. So for example, when it comes to pyrolysis, they cannot handle PVC, for example. So it is really important to have this approach of waste perspective. So we know what we are comparing: mechanical recycling, chemical recycling, and also different type of chemical recycling, from pyrolysis to solvent depolymerization. And now we also all agree on the question of the data. So we have current problems when it comes to LCA is the question of the quality and the transparency of data, as everyone has been mentioning it. And there's also lots of questions from our side on the data that has been shared with us. It's not the first primary data, so we cannot be able to make a true comparison between different recycling technology. And in most of the case, there's been extrapolated data with a lot of assumption. So there's a lot of work that has to be done to also prove and having some basis when it comes to chemical recycling, because now we don't have any data at commercial scales when it comes to chemical recycling. So it's important to have it in mind, so we are not making any assumption on not true and trustworthy data. So the idea to make true comparison between all different recycling technologies is for us to have access to primary data sets from companies. And this, when you have 3 primary data sets, we can really compare every type of technology when it comes to waste inputs and also the outcomes. And to ensure that the LCA has been done properly, this has been to be reviewed by a third-party reviewer, and also including a chemical engineer that will know where to look into it from a specific chemical point of view. So this is really important for us. And now another point that I will touch upon is assumption for future scenarios. So currently there's a lot of assumptions that are being made when it comes to LCA and chemical recycling. For example, all LCAs are taking a time frame of 2030 or 2050, based on the technology, which are currently not at commercial scale. So it's making an assumption that the technology will be working when we don't obviously know if this will be the case in the end at this time frame. So it's still some assumption. And also when it comes to making LCAs, usually it's based on a narrow geographical scope with, for example, a predefined energy mix, supposing that we will have like high level of renewable energy mixed, for example, by 2030 or 2050. This is still assumption. And also, when it comes to comparing with alternative treatment of plastic waste, sometimes there's always this comparison with incineration, but it can be in the future, not incineration being as the only solution. So what we would like to have to avoid these green claims is using the current data set that we have, for example, for energy mix, because we still have energy, we're still dependent on fossil energy. We don't have renewable energy meeting all the criteria that we want to have for 2050. And also to consider other scenarios, because we're always speaking about recycling, but the circular economy agenda aims to move forward, to go more for the upper part of the waste hierarchy. For example, when it comes to reuse, but also prevention of having any waste. So this is something that is to be taken really into account when it comes to LCAs, because this will affect type of waste that will be available afterwards for recycling. And now, to sum up a bit, what we would really like to see, it's focusing on a waste perspective to really compare all recycling technologies, mechanical recycling, and all the different type of technology that can be covered by the concept of chemical recycling. Most important as well is to have access to primary data, so we know what to compare, and there's not any assumption made on the results that are shared based on other LCAs. What is also important is to have a third-party reviewer, including a chemical engineer. So we know all the different aspects and all the subtleties of chemicals that are well understood by the third-party reviewers. And what is also really more important is to not make any assumption when it comes to future scenarios. It's important to be based on the fact that we have currently, like the current energy mix, for example, also taking into account some prevention targets or reuse target that can be introduced by any EU legislation. So it's really important to have this in mind. And also, LCA are really important to make a decision, but cannot be the basis. They can contribute to the discussion, but they cannot do all of this question. And also what we would like to have as from Zero Waste Europe is really having an LCA focusing on plastic to plastic. This upcoming discussion that will come with the revision of the PPWD, the Packaging Waste Directive, it's really important to keep on working from plastic to plastic recycling. So I thank you everyone for listening to me and open to answer to any question.
Many thanks, Loriane, and there are many questions popping up in the chat, and I will just encourage everyone, if possible, to mention the organization where they come from. It will help the debate. A quick follow-up question, Loriane. You mentioned later that the LCA tool is not sufficient really to guide policy decisions or investment decisions, actually, you mentioned. Yeah. I was wondering if you have any recommendations or ideas on what other tools or approaches could be adopted, could be taken forward beyond LCA for companies, I guess. I guess you mean companies, not policymakers. Yeah.
Companies, but also at some point as well, policymaker, because now the idea is to go towards a true circular economy, but currently, LCAs are really focusing on the environmental impacts. But if you want to have a true circular and sustainable economy, we need also to think at the production level. So what about the toxicity aspects from some production? This is not tackled directly by an LCA. So this has also to be taken into account from another perspective. So this is a part of a basis to discuss, but it should not be the only point to discuss when it comes to having some decision to take.
Okay, many thanks. If I could ask all of the panelists to turn on their cameras, it would be helpful at this stage. Yeah, very good. A lot of questions. maybe I kick off the round of questions to a more like a generic question that came in my mind. And I think that I saw in a few presentations already the need to expand the focus of LCAs, and that looking into environmental impacts is not maybe sufficient. I think it was in Christian's presentation, the socialist aspects were mentioned there, but I saw it in a couple of other presentations as well, and in the literature. So I was wondering, I mean, some of you doing research on it, others, you know, from a company perspective, is this methodologically possible and useful at this stage to try to expand the focus of LCAs into other issues, product quality, product reuse potential that I've seen in some recommendations, social aspects and stuff, or maybe it makes more sense to really stick on environmental impacts, but look into how we can improve comparisons between for specific waste streams, for example. So I think it would be good if we could have like your thoughts and even a concrete message in the end on this. I don't know who would like to start. Maybe research, you know, Robin and Florian. Maybe you have some views on this, and then we move to Martin and the rest. Yeah, if you can be concise, the more concise we are, the more questions we will take in the end. Yeah.
All right, Florian, do you want to go ahead first, and then I'll add on to you?
I mean, some of the aspects, I mean, expanding is like a broad scheme in general. I mean, some aspects there are, or especially substitutability, for example, in plastics, I mean, on a more practical level, I think also implementation, I mean, especially in incorporating economic aspects. I mean, BASF is a prime example for this with sea balance, for example. They incorporate in their assessment economic and also social aspects, more on hard facts, basically, on like in a special or in a specified methodology. I mean, there are ways to go forward, and there's a lot of stuff done in research and also in industry, but we see like the complexity just basically explodes at some point. So this is the issue. I mean, we see already, since we just talk about LCA, so only environmental aspects, it's already like there are some decisive methodology like issues that are still to be solved. Of course, other aspects are important to incorporate, but that's what we said earlier, or what Lorian mentioned. LCA is one aspect of the discussion, but it's not like the final answer, and they are not everything, and they are not all aspects will be able to be incorporated in a quantitative assessment. But this is like a political issue at some levels, I guess, right?
Thanks. Yeah.
I would like to add on. So with regards to what Florian is saying is true, but let's say we look at the environmental aspect, just the ecological aspect. LCA, a lot of studies basically right now on chemical recycling focus on the CO2 emissions impact. I mean, when we talk about LCA, we know that there are other aspects or other indicators which are being looked at. We are talking about fossil resource depletion as well. We are talking about acidification. We are talking about other aspects. And I think at the end, the question is to the policymakers, what is the objective? Are you looking at CO2 reduction, looking at defossilization, or your goal is towards channeling circularity, like what Mayu is saying, right? Circularity towards a circular carbon economy. So with this kind of objectives, the different figures that are going to come out from an LCA evaluation or a social LCA or a C balance, then that could be used as a basis to support your discussion and decision making. But the LCA is not going to pop you a value by itself that's going to give you the answer, and this is the best technology for A, B, and C. So it really has to be taken in the context and depending on what your objectives and motivation are.
Many thanks, Robin. Martin, yeah.
Yeah, I actually wanted to say something similar to Robin. It's important not just to look at the carbon footprints. I mean, LCA is already capable of generating more results. And, you know, just to make it more concrete, if one of these technologies would have a water footprint, which is extremely high, then maybe it's not acceptable in all contexts. But like Robin says, LCA is not going to give you the answer. And ultimately, there's also up to a specific situation where you need to evaluate different indicators against each other.
Thanks. Mayu, would like to add something? And are LCAs fit for your investment decisions in the end or not yet?
I think the methodology gaps that I addressed in my presentation, I think those are the ones that should be put to the development list of the wish list for LCA development. And then these other benefits, whether that's social, whether that's circularity, whatever we want to have it, maybe we can at this phase now keep it as a separate benefit. And then, have like different tools to indicate the benefits, LCA being one, and then maybe some other indicators for other types of benefits.
Many thanks. Christian, there was also a question on whether BASF whether and if and how you will improve your LCA assessment, I guess. Yeah.
Okay, but first to the other question now.
Yeah.
It's a compromise to expand to economic or social dimension of sustainability, because it expands really the resource need for such a study. Yeah, so it could balance. It could take for one LCA practitioner 1 year. Yeah, so. And when we are asked by customers, by my managers, when I have to give for investment decisions, they're asking me very frequently on chemical recycling for sure. Yeah, what's about the status on environmental impact? Yeah, we have so many requests and a C balance or an eco-efficiency analysis where you have really socio-economic studies, full holistic. It's simply not possible for all the cases what we have. I think we still are very much engaged in assessing the CO2 emissions and the benefits in a right way on chemical recycling waste streams, and also how to use it in chemical industry. We are also expanding that to environmental impacts, but there are reliable and less reliable impacts actually, yeah, and we have to improve there also. And toxicity or other aspects cannot be addressed by LCA, so therefore it's always a compromise, yeah, to expand the objective, yeah, and or the scope, and to get reliable data out of it. And I agree with Robin to say, first need to ask what is the objective, what are the questions we have to address, and what we can answer with LCA. And if the LCA is done with only a product carbon footprint, only to address this question, specific question, and if it's really done in a very good way, I'm very happy. Yeah, and I'm not a friend of to make it fully holistic. Yeah, and then when you dig into a study and it's not reliable, you can forget it. Yeah. To your question, Vasilios, how are we going to improve? We have developed also a method how to assess it in a holistic way, and how to address this societal benefit in LCA, in product LCA. And what we are doing is to standardize it. Yeah? And we want to go into discussion with our peers, with our stakeholders. Yeah. And I agree fully with Lauriane, I think you said it, yeah, we need some more comparability and some more standardized methods to be used for chemical recycling. And there we need to talk more, and we have initiated several actions already in this direction, first in our chemical sector for sure, then we also need to go to policy to say them how to assess it, then we have to go also include for sure NGOs like Zero Waste Europe in the discussion, yeah, that we all are really assessing in the same way, that we get all the same results and in a credible way, because otherwise we're all confused on that. Yeah.
Very good. Lauriane, would you like to react? And maybe you think that we don't need to expand the LCA, I don't know, stick to the environmental impacts. I don't know, you don't have to agree necessarily with the argument. Yeah.
The LCA can be a tool, but that's also a lot of points to take into account, as I mentioned before, toxicity aspects. But what's one point that is also usually tricky for us as Zero Waste Europe is that there's a lot of comparison always with incineration. But if we have to move forward, the idea is to not compare chemical recycling with the, let's say, the worst solution. So we're not going forward and comparing it, for example, with mechanical recycling reuse solutions. So then we will have a true environmental impact and not just giving the best representation of chemical recycling by comparing it with the most impactful environmental activity. So this is really a question that's also how do we compare, what do we compare when it comes to LCAs or chemical recycling?
Very good. Now moving into some, sorry, I'm going a bit faster, moving into some of the questions from the audience. I think there was a question from Martin on whether you could comment on the feedstock or the characterization of the nature of the waste that was used as input for the process your team analyzed. While you're thinking of it, maybe ask some other questions. There was a general question with uncertainties linked to LCA a bit general question, but maybe your opinion, Florian, or even the rest can comment on it. And that's a good point. For Leanne, there was a question on, could you expand on why you placed plastics to fuel and pyrolysis and gasification in the unacceptable category? Yeah. And yeah, while I'm scrolling down in the questions, in the list of questions, maybe we start with Martin. Yeah.
Yeah, so the question is which kind of feedstocks did we consider in our analyses? So we're basically working with different companies who are sourcing specific feedstocks that work for their technology. So for instance, when I talk about depolymerization, a lot of companies are focusing on PET, which depolymerizes quite well. Dissolution is especially further developed, I think, for polystyrene, whereas when it comes to pyrolysis, companies are most happy with polymers which don't contain any oxygen or chlorine, for instance. So they're most interested in sourcing PE and PP and also polystyrene, of course. So basically, in this general graph that I showed, it's based on, it's not for all feedstocks, it's for the feedstocks that companies are currently looking at. So in a way, it's like a best case, assuming that they are sourcing the feedstocks that work best for their technologies, which don't require a lot of further treatment or sorting. I hope that answers the question.
And before we go to European, yeah, there was a question on mass balance. And basically, Jason Pierce from the US is mentioned with many chemical recycling processes required a mass balance chain of custody. And he argues that LCA standards are silent about this topic, so that LCA available standards, they don't take into account mass balance approach. So what is needed to achieve a standard and accept approach for considering mass balance chain of custody in LCA? I don't know if we will have the answer or if the industry experts will have something to comment on this, but in general, any views on how mass balance in LCA can be linked, it will be helpful by Christian and Mayu afterwards. So I want to give you some time to think about it. Your opinion, Florian, yeah.
Mass balance or the uncertainty, you mentioned about uncertainty.
The uncertainty, but if you want to speak about mass balance, I'm not going to stop you.
I would like the process engineer speaks about the mass balance, and I will mention something about the uncertainty. Florian, would you go on the mass balance?
Of course. I mean, it's true, for example, in the PF methodology, there is nothing on mass balance, but especially this topic is fairly foregrown in all the methodologies for certification. Basically, ISCC, for example, has some specific rules, and there then Red Cert also, I know, has specific rules for mass balance approach. I mean, this also all depends then on applicability, basically, like what you want to do there. And of course, if the, for example, product environmental footprint would be further developed, which it is or which will be in the future, or other methodologies that could apply, or the ISOs, there will be like this element addressed there, but there are already some developments underway, right? This is as far as I know, at least.
Okay. So that's the mass balance part. I would like to address the uncertainty part, because I think it links together a couple of points which were brought up by the other panelists earlier. Maybe to start off with, I think all of us will agree that the LCA study, the results, is actually only as good as the assumptions that you are using for the study, as well as the data that you're feeding in it. I mean, rubbish in, rubbish out, right, basically. So the thing is, methodologically, as Mayu has said, and also Christian has pointed out, and Martin as well, I think all of us has pointed out, is that there's a lot of methodological issues when we are looking at LCA implementation in the CR context that has to be addressed, and uncertainty is definitely one of it. Christian, you mentioned about this, right? It doesn't make sense to have a nice study if it is not realistic. You have to talk about emerging technologies, the temporal scale, how the development is going to develop. You're also looking at the different type of waste type that could be utilized for the different types of technology. And then there's also the question, right? How are the technologies going to be scaled up? A lot of times when we talk about chemical recycling technology, it looks like we are talking about technology that is fixed, it's available, and it has this size. And when we talk about a CO2 emission, we are not asking, is it specific emission? Is it total emission? What are we looking at, right? And what's the impact altogether? So all these are issues and challenges which needs to be addressed. And there are work being done. And I think we have done some initial work in this direction. which address this specific points. So I'm really glad that these points are also brought up by industry player, by Lorraine as well, and also by Martin, because all these issues relating to prospective LCA, how does emerging technologies as it develops, how do we deal with the issues of data availability? There's a lack of data. How do we address this gap so that LCA can make a contribution to evaluation? How can we use scenarios or sensitivity analysis just to generate different alternatives, also to support decision makers, both from the industry and policymakers, to understand what happens if the situation changes. I think all are different aspects that needs to be addressed, and we are involved in this work. And if any of you out there are interested in a dialogue with us about that, we really welcome you to join us and contact us. In the report that I mentioned earlier that we did case studies. So we not only identified the challenges of LCA, the uncertainty aspects and more, we came up with recommendations, methodological recommendations to address that, and we implemented our recommendations via checklists and also case studies. So if you have a chance to take a look, and we really look forward to a dialogue with you guys on whether we are on the right track.
Good. Christian and Mayo, I don't know who wants to go first on that. Yeah.
Ladies first, maybe.
Or I can go first. Okay, so I guess the question is now on these mass balance topics, and we need to remember that we're dealing here with a transition of a very complex value chain, and we need to acknowledge that co-processing of virgin fossil material will, together with these new alternative feedstocks such as chemical recycled feedstock, will be with us for a period of time. So we are not gonna transform the whole industry into fully circular, fully renewable in a short period of time. So therefore, mass balance is a must. It's just something that we need. It's an essential tool to make this transformation real.
And Mayu, is it something that maybe that's a question for your colleagues, but me raising this, I mean, can it actually be linked with the mass balance LCA? Can it be linked with the mass balance discussion on a practical and technical level? That's something that I would be curious. Maybe you don't have the answer now, but something for food for thought. Yeah. Maybe
I think mass balance is the key enabler for the transition to circular economy for the whole chemical industry. Without mass balance, we will not achieve it. That's a simple statement. Yeah, and because we are bioplastics, we have 1% of bioplastics currently in the total plastics industry. In the chemical industry, we are 10% circular currently. So we have a long way to go. And without mass balance for the next 20 to 30 years, yeah, this will not be possible. That must be clear. And therefore, mass balance needs to be included also in LCAs, because LCAs is a tool which helps us to assess the environmental benefits of our products. And on a corporate level, for sure, of corporate footprints. So there is no question that we have to implement it. We have to implement it in the product environmental footprint of the EU Commission. We have to implement it in the EPD system, environmental product declarations for the construction industry. Yeah, for all those regulative standards, we need to implement it. The good thing is that to the good old ISO standards, it is conform. We did a lot of assessments on that, so I think that's fine. Yeah, it can be applied. That's fine. Yeah. But it must be implemented in these norms, in this regulative standards, especially here in Europe, because that is the future for substantiating green claims, and therefore you need LCA for that. Yeah, and if mass balance is missing, the key enabler for the transition to a circular economy is missing, and I think then the Green Deal, I think, will be not a Green Deal, a successful one in 10 years. Yeah. Loriana, would you like to comment on the question, but also on the mass balance, if you want to come in? Yeah.
I will start first with the mass balance and then afterwards the question. So on mass balance, I think the approach of Zero Waste Europe is quite different because, yeah, true, we need mass balance, but made at the batch level, in the sense that at each batch, at each mix of material, we need to be able to assess what is coming in and what is coming out, in the sense that at the end, when we have the final products, we know we have a trustworthy information. We know the true recycled content that we have in the final products. So we can be sure the claims that have been made reflects the true content. So if ideally it would be at each batch we can have this recycled content following it. But if it's not the case, if it's not possible, then having an attribution that is comparable, that is linked with what the type of input, so that at the end we are sure we're having the same line when it comes to the type of input and the type of output that we have, to ensure high traceability. Because if we have to go to have for food contact material, we need to be sure that at each level, the toxicity level is the right one, and we are having a strong traceability. Then now, when it comes to the question on plastic to fuel, we are here today to discuss circularity. And when it comes to recycling process and technology, the EU legislation explicitly exclude fuel production. So then if we are speaking plastic to fuel, then this is not recycling. That's why for us, it's an unacceptable activity to make, if it's clear.
Okay, thanks, Florian. A lot of questions. I'm trying to make a hierarchy, which is not easy, but there was a question on third-party certification systems. And I'm wondering if any of these systems have been applied for LCAs, but they are more for the mass balance approach, I understand. But I don't know if someone has any views on this. There was an interesting, another suggestion on why instead of LCA, we're not using a method displacement of more greenhouse gas intensive output from UNFCCC methodologies in SDN booklet, climate development mechanisms. I don't know if this is realistic or possible, but I'm wondering if any of you has looked into this. And as a third question or point that's coming more from my side, there are, of course, the LCA standards. The general one, they did not describe from ISO, they do not describe in detail the LCA techniques. They provide a framework. And I was wondering, you know, if any views from our panelists on the existing standards and whether there is a need to go further in terms of standardization. I think it was raised in a couple of presentations. And if we are to move forward this direction, which aspects should be very concretely be standardized, maybe through an international organization as well. So there are three questions are raised, and you can pick up any of them, or you know, anything that makes you feel comfortable or you have something to say. I don't know who would like to go.
Maybe I can again address certification. There are certain themes I mentioned to before, ISCC, Red Cert. The issue there, especially in terms, I mean, they certify chemical recycling, both of them. ISCC, for example, it's called ISCC Plus. The issue there in terms of chemical recycling is actually they don't apply a greenhouse gas balance for ISCC Plus certification, which is a total. I mean, they have the chain of custody and mass balance approach, which is certified in the scheme, of course, but it's missing, especially for greenhouse gas balancing in this regard, because they are basing their like general methodology for greenhouse gas calculation on the RED 2. And with RED 2, like especially like application of secondary feedstocks, basically waste, like in chemical recycling, is not really regulated, so it doesn't really fit. So there's really a big need there to really like use or make these certification schemes, which are really helpful and really practical for practical applications, to make them more reliable in their messaging, basically.
Maybe I add on that ICC and Red Cert and RSP, they all include also greenhouse gas calculations. Yeah, for the material sector. Yeah,
but for bio-based fuels, ISCC Plus does not demand a greenhouse gas balance.
Yeah, yes, that's optional. Yeah, for RSP it's mandatory, and for that is optional. Yeah, I mean, the question is whether one needs to do that. Yeah, the most important for a mass balance certification is that the input and output balance is balanced, so that you have to purchase the right amount of sustainable input when you sell something on the output side. That's very important, yeah, because otherwise you could have double counting. Yeah, the LCA is derived from that, yeah, because it should have matched the same product, yeah. And the problem is if you LCA calculations. BASF could do that. I mean, we could certify also the PCF, yeah. But I assume that SMEs and many other of our players along the value chain are not yet fit to provide for every mass balance product also a product carbon footprint calculation. It's still not there, yeah. And it should be really a level playing field. So therefore, I support that it's optional to have that in the certification. And not mandatory. Otherwise, many of the smaller players along the value chain would be squeezed out currently, and therefore I am more currently on that side to make voluntary LCA calculations on that when it's needed. Yeah, for example, for chemical recycling, it's needed. So everybody who is handling products with chemical recycling shall do also LCAs in a credible way. Also, when it's not for every product to be reviewed, but at least for the lead LCA, one should really review also such an LCA by a third party, which is independent. And I think Lorian or somebody said that it should be also a chemical engineer or at least an expert in this field who would really check those results to be credible.
Any other views on this or on standardization and whether there are existing gaps in the existing standards and what could be the way forward?
Maybe I also add a few words here, and I don't want to hide it that I'm also acting as a chair of board of directors for RSP, so that it's clear for everyone. So I think third-party certification and verification is important in order to bring credibility. They bring value by providing this verification of traceability, mass balance, LCA, or product carbon footprint calculations, like Christian well put it. So I think because this data transparency, the traceability information, that's all something that is hugely demanded by the downstream operators. So I think, and it needs to be credible, robust. And I think these third-party certification schemes can provide the credible verification that is much needed there.
Okay, so anyone else would like to come in or should I move to some other questions? Okay, there is an interesting question or comment by Ananda, who's expanding a little bit the focus of discussion, and she's saying that it might be interesting to see the views of the experts on how they consider system expansion approach of avoided emission credits, for example, incineration avoidance, to be used when discussing scope 1, 2, 3 emissions of chemical recycling based products, as avoided emissions is outside scope 1, 2, and 3 according to Greenhouse Gas Protocol. It is quite a specific question, but if anyone has something to say here, I would be curious. Then there was a question for Martin, by Muli, who's commenting whether you meant that pyrolysis process is good only for monomaterial plastics waste and not for mixed plastic waste as promised. I'm not sure you meant this, but okay, you can clarify this. There was a question for Lorian. According to your suggestion, we should compare chemical recycling with mechanical recycling or reuse, and in which way does this benefit the cause of chemical recycling, since its primary focus is to target that the other recycling methods could not process? I don't know if you have any thoughts on it, and there were some questions, some general questions or comment questioning the use of LCA in general, whether we should actually, whether to what extent LCA is a useful tool. Yeah, I mean, we can have this discussion. This is the purpose of this webinar as well, to see how LCA can be beneficial, or not only in academic debate, but also for policymakers and businesses. So yeah, if anyone has a comment on this, happy you to step in. Yeah, I don't know who wants to go.
I want to start because I have to leave to the train actually.
Okay.
Otherwise I cannot come back to Germany today. So on the scope 1, 2, 3 emissions, I think first is important that we have to elaborate this societal benefits of chemical recycling when it exists on a product level. Yeah, that's a product information to the next step that meets the customer. Also, we can compare it then with does it have a benefit with a fossil product, for example, and then competitive technologies. Yeah, that's one thing. The next thing is how can we bring that to a corporate level? Scope 1 to 3 is a corporate thing. Yeah, and I think he means or he and she means the corporate standard of the greenhouse gas protocol. That's another thing. Yeah. Double counting must be excluded. That's fully clear. If somebody takes a credit on a product basis, somebody else has to not to take this credit into account, especially when you think about the first and the second life cycle. And the same has to be also applied for a corporate level. So therefore, I think more standardization also in this direction is needed. Product category rules are needed, yeah, to exclude this double counting. If this use, so that means the upstream system expansion method, is applied, that not everybody takes the credit where he wants to take it. Yeah.
Many thanks, Christian. Yeah. And we don't want you to miss the train, so thanks a lot for your contribution. And yeah, I mean, I think it's worth spending the full. We have some questions that are very technical. I think they come also for people that might do postdocs or PhDs on the topic, so it's worth, I think, spending a few more minutes responding to some of these questions. So there was a question specifically on what are the most significant contributors, for example, input steam quality, process conditions for reactions, product composition for LCA outputs. For example, how sensitive are the LCA models for the reaction performance outputs, such as selectivity and yield, for example. That's a question more for the academics in this group. And I don't know, Lorian, Maju, I mean, there was a question for you, Lorian, but Maju, you can also react on whatever has come up in the chat box, yeah, if you want. Yeah. Who wants to go first? Yeah.
I can come on the question of avoided emissions, because for us at Zero Waste Europe, it's also a way to reduce present a reduced greenhouse gases emission for chemical recycling. Because if we compare it to incineration, of course, then with avoided emission, we will reduce the overall greenhouse emission, greenhouse emission from chemical recycling. So this is promoting chemical recycling in an untransparent way. So if we want to promote chemical recycling, this has to be made on trustworthy information and not making a comparison which will reduce at the end the overall environmental impacts of chemical recycling. So on this point, I think it was important to mention this position.
Are there any comments on the more technical questions? Yeah, I don't know, Florian, you want to say something? Yeah.
On the applicable feedstock or waste types, I mean, this is something we try to address in our report also. I mean, the type of waste not only impacts what would be the basically reference treatment system. I mean, if you compare, for example, if you have a fairly high purity plastic, I mean, it doesn't really make sense to have it compare our chemical recycling pathway, compare it with incineration, like on a general basis, because I mean the reference there would be, of course, mechanical recycling at least included into the assessment. On the other hand side, if you have mixed plastic waste, I mean the majority of plastics waste, even if they don't appear like that, are still in mixed fractions. I mean, for example, municipal solid waste in general, but also residues for mechanical recycling. There's a huge quantity there, and the net compositions there of these feedstocks really define how the quality of the chemical recycling process would be. For example, heating value for gasification processes, the olefin or polyolefin contents in mixed plastic waste for liquefaction or for pyrolysis processes. So this is actually the differentiation, what the reference and what the suitable process is for chemical recycling happens in the beginning, like with the definition of the waste. So it's an essential differentiator there.
Vasilis, could I make a comment following up on what Florian is saying, I think we heard from the different panelists as well, right? That we have to start from the waste. You yourself mentioned that, looking at the waste and then going on from there, the technology that work. Maybe I just want to throw an idea out there, also in direction Lorraine, because I know Zero Waste Europe, your position is chemical recycling, plastics to plastics. Looking at the potential of chemical recycling, the ability to address more than just plastic, for bring something back into the production chain for more than plastic, maybe it is meaningful to consider separating this to a discussion and saying there is a discussion on plastics to plastics, and let's look at technologies that can do that. Starting from mechanical recycling, you can even go further up and say, starting from eco-design, mechanical recycling, which of the chemical recycling technologies make sense, etc. And then this whole discussion for chemical recycling, maybe to broaden the scope and to say, hey guys, chemical recycling, what does it mean? Is to bring back carbonaceous waste as secondary feedstock to replace fossil feedstock for production. And then we'll go from there. Maybe it's just worth a thought to see if there's a way we can find a consensus and not say that chemical recycling has to be plastics to plastics, because I think it's not very meaningful. And sooner or later, we are going to run into a roadblock.
Jordan, would you like to react, or this is something that could be processed? It's not you have to say a yes or no right now. I guess it's not a question of agreeing, but if you have any thoughts on it in general, on shifting the debate further than plastic to plastic. I don't know if this is something that you have discussed internally or if you have thought personally. Yeah.
This is really like an interesting discussion we could have, and I think this discussion will also need to be processed internally to then after have more comprehensive approach.
Good. There is an interesting comment or question by Muli, which I missed. Since the LCA of pyrolysis or chemical recycling is always compared to incineration or energy recovery, can a plastic waste bale that is destined for incineration be diverted without any pre-treatment at all to pyrolysis or other processes? I mean, is there a process in between the step of taking a plastic waste bale from diverting it from incinerations to chemical recycling pyrolysis processes? And no, that's a good one. I don't know if somebody has looked into it. Mayu, I mean, have you, or I'm curious myself as well whether there is any.
I can try to answer, but bear with me. I'm not exactly a specialist on this field, but I think it's fair to say that pyrolysis unit would not eat whole pails, so they need to be somehow pre-treated, whether that's shredding or whichever type of activity. Like I said, I'm not a specialist in that area, so I cannot comment much further, but I think some type of pre-treatment is required.
Good. No, I mean, there is, I have just one final comment. It's not a comment, but something like that gives a little bit food for thought in order to close the discussion. There was a question like whether LCAs are making the whole discussion too complicated, and whether there's a lot of resource consumption within companies, lots of discussions, debate, and this, I guess, links to the whole discussion around chemical recycling and whether the way we focus the debate now has made things too complicated, too time consuming, too complex for non-technical experts to digest and process and make a statement or even take policy decisions. And that doesn't have only to do with European Commission policymakers, but also to actors at the national level. I think this is a good one, and maybe that's something for people to reflect. And as a final comment before we close the discussion, which I think was extremely useful for me. But I think that's a good reflection to do in the end. I don't know who would like to go first. And if you have any remarks, that's the moment. Yeah. Martin.
I can go first. I was also thinking about this actually when we were discussing, every LCA needs to be done according to a certain standard. It needs to be very transparent, and we need to have a harmonized approach for dealing with mass balancing, for instance. And in a way, I agree. But there was also a question like, why are we doing LCAs? And I think we can make distinctions there. Not every LCA is meant for policy making. We get a lot of early stage LCAs, basically, where a company is just really starting to develop a technology. They're in a lab phase. They're not working with a concrete waste stream yet. They're just trying to figure out, can we even do this depolymerization process or this dissolution process? And for them, it's difficult to start working with a realistic waste stream. And maybe if we do an LCA, it doesn't need to be externally reviewed. If we just want to know if this were possible and you could actually, find a stream where you can divert it from incineration, what would be the benefits? Or, are there any benefits? Or are you using way too much electricity or some solvent in your process, which makes it a completely bad idea? So I think a distinction can be made between very early stage LCAs, which are more exploratory in nature. It's about finding hotspots and giving preliminary advice to the technological development process, basically, which is very different from a more final stage LCA, or whatever you want to call them, in-depth LCA, which is used for policy making, which indeed, I agree, should be as transparent as possible and externally reviewed.
Good. Yeah. Your opinion, Florian? Thoughts and last comments? Yeah.
I think it's actually, there's from the perspective for what is at stake with the evaluation of processes, alternative products. I mean, there's like a whole industry or emerging industry coming up, new players, a lot of new regulations and everything, and if you're not precise with the evaluation, then it's basically, or there's a hard risk that we do this for nothing with no really effects on any like environmental or climate benefits there. And this is a common issue that is often voiced in terms of LCA, that depending on your assessment framework or how you can basically rectify anything. Basically, and this is the issue where we have to get really precise and really standardized, so we can get reliable judgments on technologies or products, or in this regard here. So I don't think at all that it's useless or it's too complicated. I mean, there are still, like, it has to be more complicated to get precise enough from my perspective.
Robin, any final thoughts? If you can do it in 1 minute to stay on time. Yeah.
Okay. Yes, I agree with Florian. I think that LCA is a good tool, but I also agree with Martin that to get so in-depth is not necessary for everything. It really depends, again, on the objectives and what you try to achieve. But if we are looking at the macro level and looking at what are the potential contributions, let's say on topic chemical recycling technologies for our society, then I think there is a need to get precise. I think there is a need to make sure we are getting the right assumptions and hopefully the best data to support an evaluation which can, facilitate a decision making for the way forward, which makes sense. I hope that's 1 minute.
Yes, very good. Lorian.
I think it's, indeed, I agree with you. One is, still quite relevant when it comes to assessing all different types of technology. And I think if we can have good basis to compare when it comes to specific issue, then it's relevant. But after, if it's really become too complicated, having a lot of different inputs and outputs, then the discussion might be going everywhere and not the way we want forwards.
Mario, please. Yeah.
Sure. Just a quick comment from my side. So what the question I hear from different stakeholders quite often is like, what is the number? And what people mean by it is like, what is the carbon footprint reduction potential of our materials, for example. And I think this level of detail is maybe getting a bit too complex, because we know that the exact number, maybe is not so relevant. But what is most relevant is if we're moving to the right direction, if we are creating a significant positive impact or not, and where are the gaps, what are the biggest sources of emissions that we should be tackling in order to become even more environmentally friendly. So maybe to close with that.
Thanks a lot, Mayu. Thanks a lot to everyone for taking the time today, dedicating 2 hours of your time for this webinar. Thanks to the participants. We had a lot of people staying until the end, although the topic is technical, although it was 2 hours, but I think it was worth it. You know, it was very interesting for me. I'm still trying to digest, but I think we made a small contribution, I hope, in simplifying a little bit some of the issues discussed and focusing on what are the key challenges and what could be the way forward. My perspective is that it's a topic, LCA assessment, that you will not find agreements in other disciplines, in other sectors where you have a lot of, where such assessments are conducted. So that's unlikely to happen on chemical recycling as well, to have like one, let's say, agreement in scientific and academic terms that this is the way forward, but that the evidence that we're getting are useful, and there is room for receiving more, and I think we need more. So I don't think the discussions are going to stop to finish in the coming months or years, but looking at the perfect solution or the perfect assessment that will give like the full picture of it, I think it's probably not going to happen. So we will try to digest all of this information today, and as I explained in the beginning, there will be more events coming out in the coming months. So we hope we keep this momentum and we continue discussing and maybe agreeing in the end, maybe disagreeing on some other issues, but that's the merit of having these discussions. Thanks all of you. Have a look at our website for upcoming activities on chemical recycling, but also on other topics as well. And you will receive the presentations via an email, and enjoy the rest of your day. Thank you.